There are lots of times in set theory where we don't want to study every single element in a set. Some sets are humongous. For example, the set of all paintings that Picasso painted. We may want to just look at a few that are in a museum or on display. Whenever that's the case, we say that the smaller set of paintings is called a subset of the larger set. So to define this, let's say a subset B, or a set B, is a subset of set A if every element of set B is also an element of set A. If B is a subset of A, we write the following. It kind of looks like a greater than or less than symbol, actually a less than or equal to symbol, but not with a V or a point, kind of as a sideways U. So there's the symbol for subset. Now, a subset does not have to contain all of the elements of set A, but it can, okay? If indeed those sets have exactly the same elements, probably won't come as any surprise that those are called equal sets. However, there is another more specific type of subset. It's called a proper subset. And a proper subset means that the subset is not equal to the original set. It contains fewer elements than the original set. So if B is a proper subset of set A, we write the following. That there is the symbol for a proper subset. If B happens to be equal to set A, then we cannot say it's a proper subset. We say it's a subset. All right, so let's take a look here at what we've got going on. Let's consider the set Mickey Mouse, Donald Duck, Tinkerbell. What set might this be a subset of? Well, again, there are lots and lots of things you could say here. I'm going to say that this is a subset of the set of all animated characters. Now you can say the set of all Disney characters, you can say the set of cartoon characters, you can define that however you want. Now the next question is this set, Mickey Mouse, Donald Duck, and Tinkerbell, a proper subset of the set you named? In other words, does the set, Mickey Mouse, Donald Duck, and Tinkerbell, contain less than all of the things in the set? Well, that is certainly not the full list of animated characters, and so yes, this would be a proper subset of the set of all animated characters. Okay, so take a look at the next one, the set Lincoln, Washington. What could this be a subset of? Now again, lots of options. You could say the set of all U.S. presidents. You could say the set of streets in a town. Yeah, you could say the set of towns in Illinois, for that matter. So you can pick your favorite. I'm going to go with the set of all U.S. presidents. Excuse me. And then the next question, is this a proper subset of the set you named? Well, since in my case, there are way more than just 2 presidents of the United States that have been in office, yes, this is indeed a proper subset. All right, now look at the set 246. What could this be a subset of? And again, you have lots of different options. You can say the set of all integers, the set of all even numbers. I'm going to limit it just a little bit more, and I'm going to say it's a subset of the set of all numbers on a 6-sided die. And is this indeed a proper subset of the set you named? Well, since it is part of the numbers on a 6-sided die, but it is not all of them, yes, once again, it does happen to be a proper subset. All right, so let's take a look at example 4 here. Consider the set D of cards in a standard 52 card deck. Give one proper subset of this set using correct notation to show that that's the case. All right, so a proper subset means it cannot contain every single card in a deck. So I'm just going to go for the Ace of Hearts and say the Ace of Diamonds. If you want to list more than that, that's fine. The symbol for a proper subset is just the sideways U, and it is a proper subset of set D, all cards in a deck. Consider the set C of classes you are taking this semester. Give one subset of this set using correct notation to show it's a subset. Well, I don't know what classes you are all taking, but I know everybody is signed up for Math 110. And I said, show it's a subset. Now you could list in this case every single class you're taking if that's indeed what you want to do, because to be a subset, you can be equal to the set itself. Regardless, I'm, for example, teaching more than Math 110 this semester. It is still a subset of all the classes in my case that I am teaching. It doesn't have to be equal, but it can be in order to be a subset. And then last thing, consider the set S of all states you have visited. Now again, if you have only been in Illinois, that's the only state you can list. I can list Illinois, I can list Hawaii, I can list Alaska, I can keep going, but I won't. And this is a subset, so again, showing that it is part of, or perhaps every single state I have visited, of set S, the set of states.